I am so glad you're here for another episode of Mechanism Monday. In last week's video, I asked if you could solve the mechanism for this chemical transformation. So if you haven't had a chance, pause the video now and try it independently. And make sure you stick around to the end because I'll give you another mechanism to solve for next week's video. One of the interesting things about this reaction is that we're taking a relatively simple molecule in formaldehyde and turning it into what is called metaformaldehyde, which is a heterocyclic compound that contains carbons and oxygens as a part of a new cycle that's being formed, just by using an excess amount of formaldehyde and adding an acid to catalyze this reaction. So the first step, anytime you have carbonyl compounds that you introduce acids to, is often going to be the protonation of this nucleophilic oxygen. So it's going to produce water as a byproduct and form a protonated version of this formaldehyde. So this is going to give us a positive charge at oxygen since it's been protonated. And from here, another molecule of formaldehyde can come in and react, just as the oxygen did previously, acting as a nucleophile to get deprotonated by an acid. This oxygen can now act as a nucleophile for this electrophilic carbonyl carbon, which is going to kick up these pi electrons. And this is how we begin to form some of our cyclic compound, which is ultimately going to contain more carbons and oxygens. So notice that we're now forming an alcohol at this position. So we're going to have an alcohol with a CH2 group, and then we're going to have the rest of our newly positive charged formaldehyde, which came and reacted at that carbonyl carbon position. And notice what we've done here is formed a brand new electrophilic carbon at this carbonyl position and kind of turbocharged it because the oxygen is positively charged, which means that another molecule of formaldehyde can come in and react nucleophilically at that electrophilic carbon position, which is how we start to generate our final product, metaformaldehyde, which ends up with 3 oxygen atoms. So the product of this transformation, we have this alcohol here, the CH2 group, with another oxygen, and then we have the rest of our molecule, which is going to be, again, that turbocharged species because we have a positive charge at this oxygen, which means that now this alcohol can act as a nucleophile for the carbonyl carbon position. So in that next step, this lone pair of electrons will act as a nucleophile for that carbonyl carbon, kicking up these pi electrons and leaving us behind with ultimately what is close to being our final product, except for that we still have a positive charge that we need to deal with, because remember, this oxygen was an alcohol, so it is positively charged. And for that, remember in our first step, we generated water as a byproduct of deprotonating this acid, which means that a water molecule can come in and deprotonate that hydrogen, generating our final product and also regenerating the acid that we added to this reaction. So even though this transformation is pretty cool in that we're generating a very different type of molecule, the reactions that take place in this mechanism are just a series of proton transfers and nucleophilic attacks at carbonyl carbons, all of which you probably learned about in your organic chemistry classes, where you can protonate the oxygen of a carbonyl compound, which will turbocharge the electrophilic carbon, making it more susceptible to nucleophilic attack, allowing for 2 molecules of formaldehyde to react with one another. And through an iterative process, we're able to generate this heterocycle where we now have a carbon-oxygen cyclic compound called metaformaldehyde. If you enjoyed this week's video, make sure to give it a thumbs up down below. And for next week's video, I'd love to see if you could figure out the mechanism for this chemical transformation. Make sure that you're subscribed to the channel so that you never miss out on another mechanism. I'll see you next Monday.